Hello everyone, my name is Nguyen, and then our project it will be or our final midterm project for image analysis. It's penalty kick outcome classification and analysis using image analysis techniques. And then starting off with the presentation outline, give a little background information on penalty kicks, looking at some literature review, like what predictors go into the penalty kicks, like what a player thinks in their mind right before they take it, go over the methodology behind our process, look over some results that we were able to discover, some conclusions, as well as the future improvements or future works that we can do. Look at, show the references, like where we got the data, and then other work that was previously done, and then looking at a live demo as well. Now, looking at the background of penalty kicks, they are the ones that can decide a match or even like a tournament. And then the motivation behind it was looking at penalty kicks and seeing if we can apply any image analysis techniques into it rather than just walking up to the penalty spot and kicking a ball. And then understanding or seeing if there's any like patterns or strategies that go behind the kicker as well as the goalkeeper. And then another important aspect is the coaches and the players, they don't have to just go up there all stressed. They have some strategy in the background so they feel more comfortable before they take the kick. And then some prior approaches, they looked at game theory, analyzing like the outcome, like, oh, if I make this penalty, are we gonna win the tournament? Or understanding the sports analysis behind it, like, will this affect my stats in the next upcoming sports game, or will this affect my contract? And then looking at the innovation aspect of it, using the techniques like classification or clustering in it. Now, what looking at the sports analysis side, the biggest uh, factors or predictors for predicting or knowing when the penalty outcome will be the composure of the player and the goalkeeper, as well as their experience. Those are probably the two most important aspects. It doesn't matter how much you practice, the composure as well as the experience will always be higher than practice, as well as the ability to read the player movements. That's where the experience comes in because they have to have the composure to read, understand their environment, but they also have the composure to carry out their tasks. Now, looking at the literature review just a little bit, majority of the time they looked at uh, it was just looking at the body instances or like the biomechanics of the body, like right as before they were about to take the penalty kick. That was the main feature that the previous research has done. They didn't look at factors like, oh, which foot that they're more dominant with, or which side the goalie was looking at, or like looking at any mind games that they had. It was more of a focus on how the player was positioned right as they're about to take the kick. That was the biggest factor that they were analyzing. And then looking at the method or our system design. So the first part was uploading the data, loading up the data set, looking at factors like which side the goalie is going to dive on or which foot the penalty kick taker, like which foot they're using. And then extracting those features, looking at the pivot table, seeing which one was the most important features. As mentioned before, the foot dominance was a major aspect in our results analysis that we'll get into that later. Looking at the modeling aspects, we use k-means clustering as well as decision trees, and then the clustering was able to help. It can help the players or the goalkeeper, depending on which side you're looking at. It can help with determining any penalty strategies as well as predicting penalty kick outcomes. And then the confusion matrices as well as the classification reports were used to predict or evaluate the predictive performances that we had. And then we wanted to do out visualizations using heat maps as well as the bar graphs to show the average of the cluster and in like retro in perspective of the time that they take the penalty kick to see if that plays a major role in it. Like if they were later on in the match, would they play safer or will they risk it, knowing that they have to win a score to win the game, or if it was just to get a draw, that was a big part of the research. And then I'll carry it on to my partner Bella, who will go over the rest of the results as well as show the demo for it as well.
So in terms of results, there's some good news and some bad news. The bad news is that the k-means analysis didn't really show anything for our data. All the clusters were pretty close together, and there wasn't a huge amount of difference between them. And so we've chosen not to show that data. But what we've shown here is, so for a kicker kicks the ball to one way or the other, left, right, or towards the center of the goal. The goalie dives towards either left or right, or he stays in the center, and this is how successful each of those matchups are. So closer to 1 means the shot went in, closer to 0 means that it was a miss or a save by the goalie. And so you can immediately see some differences between them. For example, left-footed shots are more successful um, when the kicker and the goalie both dive to the same side. Um, Whereas, for example, a right-footed kicker is more successful going towards the center when the goalie goes to the left. Um, Overall, not a huge amount of trend here, but you can definitely see initially that there are some differences in the data that we were analyzing. So we went and we made a decision tree and we made a confusion matrix based on that. And so again, 1 means a goal, 0 means a miss or a save. As we see here is that the decision tree for this data is pretty good at predicting when something's going to go in, but it's not all that great at predicting when something's going to miss. And part of that's probably an artifact of the data where there aren't a ton of shots that missed. I think you see over here, in the realm of 85% of all shots overall go in. And so there's not a ton of data of shots that don't go in. And as this indicates, at least for the decision tree, it was hard for the algorithm to detect patterns in what would make a shot not go in. So it could detect when things were pretty certain go in, but not so much when things were pretty certain to not go in. It didn't really find a huge amount of trends there. So one thing we did with the decision tree is try to extract which features are most important, which features are most significant in determining whether this whether a ball is going to go in the net or not. Because ultimately, this is what's going to be helpful to consumers. Ultimately, this is what's going to be helpful towards people who are making decisions, right? This stuff over here could be useful for informing which way should a goalie generally run for a kicker who's known to kick with their left foot more often, or a kicker who is seemingly lining up to kick to the left, which way should the goalie dive based on this data. Over here, though, is kind of looking more at bigger picture things. And so one thing that's maybe kind of surprising, but maybe also a little bit obvious, is that the minute number in the game is the highest predictor of whether a shot is going in or not. In other words, the further you are into the game heavily impacts whether a shot is made on a penalty or not. That's impacting more than whether you're the home team or the away team. That's impacting more than which way the goalie goes, which way the kicker goes. After minutes, the most important things are the number of home goals, and then whether someone slides to the right, and then away goals. And so that's not necessarily surprising. You would expect that if a team is scoring more goals than overall, shooting better, they might shoot better on penalties as well. And anyway, because the minutes was the main one that was really, really obviously statistically significant, we really tried to bore down into that one and see exactly what was going on. Are players getting tired and they're missing as the game goes on? or maybe are they getting better throughout the game, or is it just kind of random but a lot of diversity? And so we looked at basically a bunch of minute intervals over the course of a 90-minute soccer game, and the average outcome again, that's essentially the percent of penalty shots that go in. And so what you generally see is that the average penalty shot success rate increases as you go throughout the game, with a little bit of a drop at from 20 to 29 minutes, and then an incredibly steep drop right at the end of the game, which is really interesting data. Not that it necessarily informs decisions about which way do you go on a particular play. That's probably more so what this would be informing for. But it could be interesting for in terms of how high risk are certain fouls. If people are missing penalty shots a lot more at the end of the game, maybe you can play a bit more risky at the end of the game. These are the kind of things that maybe coaches would think about with this kind of data. So the general conclusion from that is that all these sentimental things about soccer, and then as well as things like shot placement and match minute, can be really impactful on whether these shots go in. There can be certain good versus bad matchups between a shooter and a goalie. Certain situations where, you see down the center line, if the goalie stays in the center, they're either guaranteed to save it or they're guaranteed to lose it. And so there is a bit of psychology to which way do you go, and maybe this data could help inform that. Overall, what this shows is that analytics can guide decision making, but it's not the end all be all. Ultimately, the analysis is about trends, not the high variance that you see in these kind of sports. So in terms of future works, it would be nice to have access to more leagues and more tournaments. This is from a particular set of data, so having more data could allow us to further hone the analysis that we do here to make it a better model overall across the sport. The other maybe could be looking at more miss data, because again, we had probably overall about 85% data was goals, which doesn't leave you a whole lot of stuff to predict misses. And we saw their algorithm was pretty bad at detecting misses, detecting at predicting misses. And so being able to get a larger sample size of that kind of data could be helpful for improving this algorithm going forward. The other thing is other kind of sports. The kind of processing that we do here isn't necessarily unique to soccer, and it absolutely could be applied to other sports, and as such. So what I'm going to do right now is walk you through a demo of our code, just basically going through the results that I just shared with you guys. If I can exit out of this tab. All right. So what I'm going to do first is I'm going to restart the session so all the variables are reset. All right. So first I'm going to, this is basically just uploading the Excel file that we have our data in, making sure the Excel file only has what we want it to be in it when we're processing it, making sure that we have all our headers defined, and then starting to process this data in order to get us these outcomes differentiated by whether it was a left foot shot or a right foot shot. So we again tried to do some k-means analysis. It didn't work super well for our data, so we went on to decision tree, and so we're going to start running that as well. That's an error, so we need to run this one, and then go back to this one, a little quirk of the code. And now we start to get into the more stuff in the data. So you can see, F1 scores are not phenomenal. for again, as I was saying before, for predicting a goal, that's a good F1 score. For predicting a miss, that's awful. And so that's definitely something that we would need to improve going forward. And then down here, finding all these things that I described previously in the results. So if you have any questions, happy to hear them.